Hi friends, welcome to GMAT Points videos. So in today's video, we are going to do a overview of the quantitative section. I'll be explaining the exact format of the quantitative section, how many questions are there, what type of questions are asked, and we'll also be solving many questions along the way. So let's get started. First, let's take a look at what is the section, what are the questions that come in the section, and everything about the section as first. So firstly, there will be 31 questions in the section and 62 minutes. So basically 2 minutes per section, per question. None of the questions are skippable. The GMAT is a computer adaptive test, which means that each answer, essentially whether you have gotten a question correctly or incorrectly, determines the next question you're going to get. Which means that you can't skip a question, you can't go back to a question. You have to answer a question to move ahead. Which also means that you should try to make sure that you leave or take around 2 minutes per question so that you are not left with very little time for the remaining questions. It is entirely possible to keep it within 2 minutes per question. Always remember, if you are solving questions correctly, you keep on getting harder and harder questions as such, because if you're solving it correctly, you get questions of a higher difficulty level. If you get a question do a question incorrectly, you get a question of a lower difficulty level. That is basically the adaptive nature of it. Basically, it tries to find out, the test tries to find out what is your level of answering a given question. If you are able to answer a question, then a more difficult question will be placed to you. That, however, does not mean that if you find an easy question, it does not mean that your last answer was wrong. That need not happen. For example, if you're moving between topics, you will find a new question because you're facing a new topic for the first time. Similarly, at times the questions might be out of order, or some new question might be placed which you feel is very easy, but that is not the case. So it does not mean that if you face an easy question, it does not mean that you made a mistake in the previous question. Just remember that. So do not lose confidence. 31 questions are, all of the 31 questions are easily doable in that 62-minute window. And just remember that you have to answer every question as it comes. Now, the scale score that you get for quantitative section would be from 6 to 51, 51 being the highest. Now, having the 51 score does not mean that you got all questions right. Neither does it mean that if you got a question wrong that you won't get 51. 51 essentially indicates that you are at the very higher end of your score as such. So, from the score is essentially scaled from 6 to 51, and the increment or decrement is always of 1 point. So, it will be 6, 7, 8, it won't be 6.5 as such. The number of options per question are 5. So, this is the basic information of what you're going to face. You're going to face you're going to face 31 questions. When options are given, you will be facing 5 options. You have to select among them to move forward. You cannot skip a question. If you are facing a question you can't answer, just pick one of the answers. Any answer, use option elimination just to move ahead, because if you waste too much time, you will have less time remaining for questions that you can actually answer. Okay, so this is about the nature of the exam, what you can expect on while facing the exam. Now let's take a deeper look into the quant section itself. What is asked in this particular section? So the first type of distinction between the questions that are asked is that there are 2 types of questions that are generally asked. One is data sufficiency and the other type is problem solving. You can expect roughly a 50% split between these two, but not necessarily 50-50. So essentially data sufficiency question and problem solving questions are just of different format, but they are based on the same concepts or topics as such. The topics are arithmetic, algebra, geometry, and word problems. Now, word problems are essentially also based on algebra, arithmetic and geometry. They are just in a different format as such. So generally what will happen is that you will either face a question which is of data sufficiency and you have to use data sufficiency solving techniques to solve it. The underlying might be based on underlying question that is to be answered might be based on arithmetic, algebra, geometry. The problem solving questions would be similar. You have to find an answer in that case. In data sufficiency, you just have to answer whether the answer can be determined uniquely or cannot be determined using some of the statements that are given. In problem solving, you have to actually find the answer. So for example, in data sufficiency, you will be given two conditions saying that sum of the roots of an equation is 8. Roots of equation say is 8. Okay, and statement 1 would be one of the roots is 3, statement 2 is product of the roots is 5. So something like that, you have to then figure out what statement alone can help me get the answer. So if it is given that x equal to 3 is one of the roots and the second statement is say product is equal to 5. Now essentially in this case what you have to do is, can I find the value or the answer the question that is asked using statement 1 alone? Then I have to say that can I answer the question using statement 2 alone? Can I answer the question using both the statements? So that is basically the data sufficiency kind of question. You have to use the same concepts of arithmetic, algebra and geometry, but the format of the question is different. In case of problem solving, you won't be given statements and you don't have to determine whether there is enough information to calculate. You have to actually solve and find out what are the roots. So basically the underlying concepts remain the same, just the way of asking the question changes in both cases. Now arithmetic, algebra and geometry, most of you would know, we will be taking a closer look of what exactly comes in each of these subsections in the coming slides. But essentially I want to say that the word problems are not essentially different from what is there in arithmetic, algebra and geometry. They are also based on these concepts, but they are based on slightly different versions of the same concept. So basically you will have time, speed, distance, time and work, profit and loss, interest, all of these questions come under word problems. But if you think of it, that is the underlying concept is arithmetic as such. Okay, so these are the basic distinction. You have data sufficiency questions, you have problem solving questions. Both types of questions are based on either arithmetic, algebra, geometry or word problem topics. So now that you understand what exactly actually comes in the quant section, we will be taking a closer look at each type, that is data sufficiency, problem solving, and then each topic. So let's get started with the first type. Before we go to that, let us first discuss what are computer adaptive tests. So as I had mentioned earlier, GMAT is a computer adaptive test, which means that the 31 questions that are there, okay, the 31 questions that you face during the exam, they are not preloaded. In most of the exams, what do you see? You see that the 31 questions are directly preloaded into your so 1 to 31 would be already preloaded into your system so that you will be answering them sequentially. But this is not the case with GMAT. The second question is fetched after evaluating the first question's answer. So basically based on whether you got the first question correct. So if you got the first question correct, a particular question is fetched as second question. If you get it incorrect, then something else is fetched as the second question. So this basically means that the questions you face would be determined by what responses you give. If you give correct responses, you will get a particular set of questions. If you give incorrect responses, you will get a different set of questions. So even people who are giving GMAT in your at the same time as you will not have the same test as you, because their answers will be different. Okay. Also their starting points would also be different. So in this case, just remember that the questions you face, the difficulty of the questions you face is indirectly determined by what answers you have given. If you have given a lot of correct answers, you will be facing questions of a higher difficulty level. If you have given a lot of incorrect answers, you will be facing more questions of a slightly easier level. Okay. So now that you understand how the test is going to function, let's start with, also let's take a look at the scores. So remember that I mentioned that your scores will be from Q6 to Q51. These are scale scores. Essentially, it does not mean that you got Q51, does not mean that you got 51 all questions right, nor does 6 mean that you got all questions wrong. It basically is a scale score indicating what was the difficulty of the questions you faced and how many of them did you get right. So it is also scaling, or it is also considering what was the difficulty of the questions you actually faced. So always remember, the final GMAT score that you get is a weighted average of the quant score plus your verbal score. So we have a blog which essentially tells you how much your quant score, if your quant score is this much, your verbal score is this much, how much your GMAT score will be. Now this weighting is, it's a slightly not very intuitive as such of GMAT score and verbal score. But I would just say that instead of actually focusing on how the final GMAT score is calculated, instead of that, just focus on getting as high a score in quant as possible. Our goal should always be to get this Q51. If we get 51, we will be moving very close to our target of a 750 plus GMAT score. So that is the basic thing that you should remember. Don't fret about why did I get an easy question. Don't fret about am I getting too difficult questions or anything of that sort. Your target should always be to get answer as many questions that are thrown at you correctly and try to get as close to the 51 score as possible. Okay, so now that I've laid the groundwork, let's actually take a look. I'll first take a look at problem solving and then take a look at data sufficiency. So in problem solving, as I mentioned, in this case, you have to actually solve and get an answer. It's not enough that you know what the answer is or whether the answer is determinate. You have to actually solve and get an answer. So for example, these are the standard questions that come in most entrance exams or the most aptitude exams. So you have to basically say solve for X. And all the options 1, 2, 3, 4, 5 would be the possible values of the answer, and you have to pick which of these values is the value of X. So that is the standard question that all of us are used to. So that basically those kind of questions are called problem solving questions. We'll also take a look at the second type of question, which is data sufficiency. So I'll give you an easy question on problem solving. So what I want you to do is, while solving this seeing this particular video, pause the video whenever you see a question, try to solve the question on your own. If you are not able to solve the question, then you can go ahead and see my solution. But always sit with a pen and paper and try to solve on your own, because that will actually help you more than just viewing a solution passively. So go ahead and try to solve this particular question. Now, in case you have been able to solve it successfully, very well done. In case you have not been able to solve it successfully, no problem, because in this particular video, I'll be covering most of the ideas or formulas that are required as such also. So here I'll just be giving you an idea of what formulas are required to solve this particular question. This is a question based on averages. So the only formula that you need to know is how do you calculate an average, and this is something most of us know. Average is basically average is equal to sum of the elements divided by number of elements. In this case, you have boys and girls. Suppose that there are A boys and there are B girls. Okay, if this is the case, what does the first sentence tell us? The first sentence tells us that A plus B is equal to 600. What does the second sentence tell us? Average height of all boys is 160 centimeter, which means that sum of heights of boys divided by A is equal to 160. So basically what does this mean? Sum of boys' heights is equal to 160 times A, because averages, if you take A in the denominator, you would get the average, which is 160 centimeter. Similarly, the next sentence tells us that average height of all girls is 150 centimeters, which means that sum of girls' heights is how much? This is equal to 150B. Now, what does the next sentence tell us? The average height of all boys and girls combined is equal to 154 centimeter, which means that sum of girls' heights plus sum of boys' heights How much is this? This is equal to 154 times A plus B. Now from the, if I add this this equation and this equation, what do I get? I get the left hand side of the equation. So this means that 160 times A plus 150 times B is equal to 154 times A plus B. If I solve this equation, I take this is equal to 154A plus 154B. And if I solve this further, I get 6A is equal to 4 times B, or rather A is equal to 2 by 3 times B. Now I have another equation that I can actually place this particular information in. That is this equation. A plus B is equal to 600. Now if A plus B is equal to 600 and A is 2 by 3 times B, then I can say that 2/3 of B plus B is equal to 600, or 5B by 3 is equal to 600. So B is equal to how much? B is equal to 360, which means that A is equal to 2 by 3 times that is 240. So we are asked, what exactly are we asked? We are asked, find out the absolute difference between the number of boys and the girls in the class. So we are asked for the absolute difference between A and B. The absolute difference, that is modulus of A minus B, is equal to modulus of 240 minus 360, so that is 120. So the right answer is option B. In this case, what did you really need to know? You needed to know only the average formula. If you knew the average formula, this was very easily doable. Now these are the kind of questions that actually come. You might feel that this is an easy problem solving question, but something like this can easily come in actual exam. So this is the basic concept that you require for problem solving. You have to actually find the answer, and you will need basic concepts from arithmetic, algebra and geometry to do that. Now let's take a look at the next question. Find the highest power of 6 in 25 factorial. Now this is a question based on algebra. Here, what is a factorial? A factorial is given in the definition. N factorial is 1 into 2 into 3 into 4 till n. So it's a product of all natural numbers up to n. So 25 factorial would be what? It would be 1 into 2 into 3 till 25 factorial. I'll give you a general formula for questions like this, to how to answer questions like this. But in case you don't know how to answer questions like this, always remember, whenever you are stuck in something where, in algebra especially, where you don't know how to go about it, try to use the method of induction. So method of induction is basically, whenever you have a large number like 25 factorial, instead of working with the large number, you start off with the small number and try to see if there's a pattern. So instead of starting with n is equal to 25 factorial, 25, instead of that, say that what is the highest power of 6 in 1 factorial. So 1 factorial is just 1. So what is the highest power of 6 in 1 factorial? 0. Similarly, if I consider 2 factorial, there is no 3 in 2 factorial. So again, highest power of 6 will be 0. 3 factorial. 3 factorial is essentially 6. So highest power of 6 in 6 is 1. Consider 4 factorial. Again, it will still remain 1, because essentially when I have 4 factorial also, 1, 2, 3, 4 divided by, like if I try to figure out how many 6s are there in this particular what is the highest power of 6 which I can get out of this. See, what I basically see is that I need, for 6, I need powers of 2 and powers of 3, because essentially this is 2 times, suppose I have to say, I say that n is the highest power. So I have to figure out 2 raised to n into 3 raised to n, such that the denominator entirely cancels off. So in this case, what do I see? I see that there are many powers of 2, because a power of 2 comes every 2 digits as such. So there will be many powers of 2, but there will be lesser powers of 3. So if I have to find out the highest power of 6, I essentially have to find out what is the highest power of 3. Because if I consider even in 5 factorial, the number of powers of 2 and 3, the powers of 2 have 4 is the power of 2. Similarly, 5 is not a power of 2 or 4 either. But if I go to 6 factorial again, 6 is a power of 2 as well as 3. So by the time I consider till like 9 factorial, 10 factorial, I see that there are a lot more powers of 2 than there are powers of 3. So if I have to cancel, it is far easier for me to cancel 2's than it is for me to cancel 3's. Which means that the limiting value for power of 6 is actually 3. So essentially this becomes, we have to find out the highest power of 3 in 25 factorial. Now how do I find out the highest power of 3 in 25 factorial? I see how many times 3 comes in that particular product. So how many times does either 3 or a multiple of 3 come in 25 factorial product till 25 numbers? So you have 3, 6, 9 till 24. So there are essentially 8 multiples of 3 in this particular product. So what does this mean? This means that there will be 8 powers of 3 till 25 factorial. But there is one more catch. If you look at the number 9, 9 is 3 square, not just a multiple of 3, it's 3 square, which means that 9 would be would contribute 2 threes. So it would lead to a higher index as such. So though there are 8 multiples of 3 till 25, because of 9 we have to also consider the multiples of 9 in this particular product. So how many multiples of 9 are there? There's 9 and there's 18. Okay, so there are 2 more multiples of 3 in this particular product. How many? If you have 27, say 27 is 3 into 3 into 3, so that is 3 cube. So 27 would mean that you have to consider one more product, one more value of 3 in that particular product. But there is no 27 in this case, so we can stop with 9. So how many multiples of 3 or how many power, what is the highest power of 3 in this particular product? That would be 10. So what is the highest power of 6 in 25 factorial? That is equal to option C, that is 10. I would give you also a general way of solving. In general, if you are asked what is the highest power of x in y factorial, so you have to find out highest power of x in y factorial. First thing that you do is, so x, highest power of x in y factorial. First you have to find out whether x is a composite number or is it a prime number. If it is a prime number, I can directly calculate what is the divisor that I have to check with. So for example, if it is highest power of 5, I can just directly take that particular as the divisor. If it is a composite number, you have to find out, you have to prime factorize x and find out which is its largest prime factor. In this case, once I prime factorize 6, the largest prime factor was 3. So in this similarly, I have to consider what is the largest prime factor of x, and you have to consider that and find out the highest power of x in y factorial. So once you have figured out, okay, this, let's say this value be the divisor d. So d is the largest prime factor of x, or d is equal to x if x is equal to prime, if x is prime. So in this case, what do? You say the highest power of x in y factorial is equal to, you have to consider floor function y divided by d plus floor function y divided by d square plus floor function y divided by d cube and so on. So in this case, how would you actually apply? So in this case, floor function is basically greatest integer less than or equal to the number. So if I say floor function of 6.33, the greatest integer less than or equal to 6.33 is how much? That is just 6. Even if it is 7.9997, the greatest integer less than or equal to 7.99997 would still be 7. Okay, so that is the basic idea. In this case, what would the value be? So we have to find out highest power of 6 in 25 factorial. The largest prime factor of 6 is 3. So I have to consider this as 25 by 3 plus 25 by 9 plus 25 by 27 and so on. But 25 by 27 would become 0. So, and the greatest integer will be 0. So, all terms from here become 0. So, this is equal to 8 plus 2. So, that is 10. Same answer as we found from a long form. But if you remember this particular formula, it becomes easier for you to calculate the highest power of any number in any factorial as such. So, the right answer would be option C, 10. Now let's take a look at data sufficiency questions. I had mentioned earlier that data sufficiency questions are also based on the same concepts that we have in problem solving. The only difference is that every question is of the form where you are given a question, you are given some information, okay, there is some information, and then you are asked, okay, is x or something, some question is asked which you have to either answer as yes or no, or you have to determine is x rational. What is the value of x? It might not necessarily be a yes or no question, it can also be a question where you have to find out the value as such. But the point of this is that you have to find out answer some specific question, and you are given two statements, statement 1 and statement 2. The objective of the question is not to figure out whether the question can be answered. It's whether to figure out is the amount of information in front of us sufficient to answer the question. So if you have the info, you have to first check info plus statement 1, can I answer the question? Okay. Similarly, you forget statement 1, then you go to info plus statement 2, can I answer the question? Okay. In case both of them do not even individually lead you to the answer, you consider if info plus statement 1 plus statement 2, can it lead me to the answer? So using that, you have to then select one of the 5 options that are there. Just memorize these particular options because they are going to stay consistent throughout. They don't change the order of the options or the content of the options. So you basically, if you could answer the question using statement 1 alone, then you have to, but not statement 2 alone, you have to choose option A. If you could answer the question using statement 2 alone, info plus statement 2, then you have to choose B, but not info plus statement 1, then you choose option B. If both statements 1 and 2 are needed to actually answer the particular question, then you choose option C. If each statement alone, that is info plus statement 1 gave you a particular answer, info plus statement 2 also gave you a particular answer, these two need not be the same answer as such. So if x's value is asked, info plus statement 1 gives me x is equal to 5, info plus statement 2 gives me x is equal to 6. Since each statement alone is individually alone or sufficient to find the value of x, I can then choose option D, which is each statement alone is sufficient. If after combining both statements also I cannot find the value of x or I cannot answer the question, then I will say that statements 1 and 2 together are not sufficient. So this is the basic format of a data sufficiency question. You are not actually required to find out the answer, but find out whether the answer is determinate or not, can be determined using the information that is there. So that is basically data sufficiency questions. You will understand this better with the help of a few questions. So consider the following question. Is the median of a list of numbers equal to one of the numbers on the list? So you have given the question directly, no info is given in the question. Directly you are asked, is the median of a list of numbers equal to one of the numbers on the list? That is the question you have to answer. So this is a yes or no question as such. Consider just statement 1. If I consider statement 1, what do I get? Statement 1 is that the list consists of 199 consecutive even integers. Now, if this is the case, what is the median of a particular set of particular list as such? So, for consider 1, 2, 3, 5, 9, 12. So, in this case, there are 6 elements, okay. A median is basically in case there are even number of values, if there are even number of elements, it is the average of the middle 2 elements. So, this would be 3 plus 5 divided by 2, that is 4. So, in this case, the median is not actually one of the numbers of the list. On the other hand, if you have an odd number of numbers, so for example, 15 over here. So, if you have an odd number of numbers, then what would be the case? What would be the median? If you actually arrange all the elements, you would see that the median would be the middle element. So, if there are odd number of numbers or elements, that is basically the middle element when you arrange the set in an ascending order. So, the first thing is that once you get the set, arrange it in ascending order. Whatever is the middle element would be the median. If there are 2 middle elements in the case of even number of elements, then the average of those 2 middle elements would be the median. So, basically when would a median be one of the numbers of the list? It would be one of the numbers of the list if either the numbers are such that if it is like odd number of numbers, the list contains odd number of entries, then the median would be a number on the list by default because it's the middle element by default. So, if there are odd number of elements, the median would be a number of the list. Another way in which the median could be a number on the list is if the middle 2 elements are same or identical. So, in that case, suppose if you had 1, 2, 4, 4, 9, 12, the average of these two would still be 4, which would mean that in this case also median would be a number on the number in this particular set. So this is the way in which you would have median to be equal to one of the numbers of the list. So let's consider statement 1. Statement 1 is the list consists of 199 consecutive even integers. Now it doesn't matter whether they are consecutive or even integers, since there are 199 elements, since there are an odd number of elements, the median would be a number on the list. So statement 1 alone is enough to answer the question. Okay, so yes, 1 alone is enough to answer the question. Now consider statement 2. The list consists of 200 consecutive integers. Now if it is 200 consecutive integers, what does it tell you? So firstly, there are an even number of integers, and the middle two elements, since they are consecutive integers, they won't be equal. Now since they are not equal, what will happen? That would mean that their average would be a decimal number. They are consecutive integers. So consider like 4 and 5. If I take the average of it, it would be 4.5, which would mean that in the second case, the median would be a decimal, which is not a part of the list as such. So in the case of statement 2, the answer would be no. In this case of statement 1, using statement 1 alone, I can answer the question to be yes. Using statement 2 alone, I can answer the question to be no. So it doesn't matter whether the answer is yes or no. In both cases, the answer is determinable. So in this case, I can answer the question using either of the statements alone. That means each of the statements alone is sufficient to answer the question. So the right answer is option D. I have not put in the options over here, but you should just remember the options always. First option is statement 1 alone is enough, but statement 2 alone is not enough. Second option is statement 2 alone is enough, but 1 alone is not enough. Third option is both together are enough, but individually each of them is not enough. Option D is each alone is sufficient to find out the answer. Option E is both together are not sufficient to find out the answer. So in this case, because we found that both sentences or both statements alone are sufficient to find out the answer, we have to choose option D. Now let's go to the next question. So this is also a data sufficiency question. See, in the first case we had median, statistics based question. In the second question, we have a question where we have to find out how much is the total chocolates that they had. So this is a worded question essentially. So the base or the topic can change, but the format remains the same in data sufficiency. So the question is, Howard and Rajesh had a certain number of chocolates with them. How many chocolates did they have in total? So we have to find out how many they had in total. So let's say that A is the number of chocolates with Howard and B is the number of chocolates with Rajesh. So we have to find what is A plus B. So what is the first statement is Howard and Rajesh had chocolates in the ratio 199 is to 97. So this basically means that A by B is equal to 199 by 97. Now this could mean that A is equal to 199 and B is equal to 97, or A is equal to 2 times this. So this would be 400 minus 2. So that is 398, and B is equal to 194. So there could be multiple values for A and B, and similarly A plus B will also be different in each case. So statement 1 alone does not give me a unique value or a unique answer for what is A plus B. So statement 1 alone is not sufficient to answer the question. Now let's take a look at statement 2. The difference, so I'll ignore this. One of the mistakes many students make is that because they have written down some amount of information, they use it or carry it over to the second statement. You have to start from a blank now. That you have to basically say this is already done. Now I have to consider statement 2 alone in isolation. So statement 2 alone is that the difference between the number of chocolates with Howard and Rajesh is less than 204. So that basically means that modulus of A minus B is less than 204. So that is the difference between A and B is less than 204. Now just by knowing the difference, can I find out the value of A and B or A plus B? A can be 208 and B can be 5, and this condition can be satisfied, or A can be 208 and B can be 10. And again the condition is satisfied, and the value of A plus B in both cases is wildly different. So again statement 2 alone is not sufficient to actually answer the question. Whenever you are not sure, this is an easy question, but in case you are not sure, try to negate that option. So try to say that, okay, there are multiple cases where this particular statement holds true, but I don't get a unique value for my particular, for what I had to actually answer. So in this case, I don't get a unique value for a plus b, because though the condition is met, I have multiple cases where that condition is met, and therefore I have multiple possible values of a plus b. So both statements alone are not enough. Now let us consider both statements together. So consider the case that modulus of a minus b is less than 204 and a by b is equal to 97. In this case, clearly a and b have to be positive integers. They cannot be negative integers, because it is the number of chocolates that they have with them. So this basically means that a would be something of the form 199x, b would be of the form 197x, and this minus this is less than 204. So what is the difference? Essentially this would be 102x is less than 204. Again, the number of chocolates that they can have with them have to be integral, positive integers, which means that x has to be a positive integer, which means that x is a positive integer. If I divide throughout by 102, x is a positive integer less than 2, and there is only one positive integer less than 2, that is x equal to 1. Which means that Howard in this case would have a will be equal to 199 and b will be equal to 97. So I can then figure out that a plus b is equal to how much? It will be equal to 299 minus 3, so 296. So again, in this case, I did not have to essentially find out the answer also. I just had to figure out whether if I take those two statements together, can I find out the answer. In this case, I found out that since there is only one possible value each of them can take, such that the difference, absolute difference is less than 204, I can determine the answer as such. I could have essentially stopped at some point over here where I realized that x had to be equal to 1, and once I realized x had to be equal to 1, I need not have actually found out the value or the value of a plus b, because I knew that once x is determined, all the remaining aspects can easily be determined. Okay, so this is the basic idea of how you solve data sufficiency questions. You need not go to the final answer. You have to just figure out whether the answer can be determined using the amount of information we have. In this case, we had required both statement 1 and 2. So the answer or the correct option would be option C. Both statements are required and each of them alone cannot give you the answer. Now let's take a look at the different topics that are there in the quant section, starting with arithmetic. Arithmetic most of you would be comfortable with because it is something that is taught almost throughout the school as such. So in this you will have to know the properties of numbers. So if you remember the number line, so if you remember the number line from school, you had 0 over here, and then you had real and complex numbers, you had rational and irrational numbers, you had whole numbers, natural numbers, integers, fractions, decimals. All of those are basically definitions of different types of numbers. So real and complex, rational and irrational, then integers and fractions and decimals. What are whole numbers, natural numbers? All of these are essentially definitions that you need to remember as such. Similarly, essentially you will have to also remember what are factors and multiples. So apart from properties of numbers, you should be able to factorize the given number. So factors and multiples, and from this also comes the concept of HCF and LCM, which is the lowest common multiple and HCF is highest common factor. So these two are essentially interrelated concepts, and these come quite a bit in data sufficiency as well as a bit in problem solving also. So basically the question can be that is x a rational number, and you would be given some conditions where x is say a root of a quadratic equation or x is one of the roots of some polynomial equation. So there you have to answer the question, is x a rational number or is it an irrational number, or if x is a real number or is it a complex number. So for that you firstly need to have a good handle on what are the definitions of each numbers, and after that you would also use concepts from algebra etc. to answer those questions. So here you need to understand what are numbers, what are the different definitions of numbers, how to factorize a number, how to get the multiples of numbers, what is the least common multiple and highest common factor. Also one thing that you need to know is prime numbers and composite numbers. This is also something that is asked. In general, you might be asked in data sufficiency, is x a prime number, and some information is given about x. It would help, it is not absolutely necessary, but it would help if you can remember the prime numbers that are there from 1 to 100. If you know how to write them down, that would also help us. So always remember what are prime numbers, what are composite numbers. It isn't absolutely essential, but it would ease the process quite a bit if you can remember the prime numbers from 1 to 100. Now, apart from this, you would also have arithmetic topics of ratio and proportion, averages and percentages. So basically, you will have to calculate what is the average of n numbers. Is the average a decimal number? Is it a decimal? Is it a fraction? Is it an integer? Is what is the percentage of the whole? So all of these, like x is y percentage of z, then find out x, y or z. So all of these are simple arithmetic questions. So it just require you to actually take the word problem or take whatever is given, information is given in words, and write down equations and then solve them. So that would be one of the most fundamental things that is asked in arithmetic. Apart from this, you would also have powers and roots. So basically you would need to know, okay, what is the nth power of this number, so a raised to n, and also nth root of a. All of these would also come over here. So in this case, generally what I would also suggest is that have a good idea of where the square roots lie. You need not remember this or remember this by heart, but you should basically know that, okay, instinctively you should know that the square root of root 7 would lie between 2 and 3, because root 4 is 2 and root 9 is 3. So root 7 would lie between 2 and 3. So having a understanding of powers and roots would be very useful in solving questions of this type. Basically understanding where in what range would the square roots lie, cube roots lie, etc., and where would the powers lie as such. If you are able to get a rough estimate of that, it would help you quite a bit in solving these kind of questions. Then you have questions on descriptive statistics. So what is descriptive statistics? That is basically questions on mean. Mean is nothing other than your arithmetic average. So just basic average is also called as mean. So mean is the average of all the elements in a particular set. Then you have median, you have variance and standard deviation. All of these definitions you should know. You should know what is standard deviation, you should know what is variance, you should know what is median, you should know what is mean. Okay, these are very basic statistics. Just you have to know the descriptive statistics given any set. So you'll be given any set and you should be able to find out its mean, median, standard deviation and variance. So closely related to the topic of descriptive statistics is the topic of set theory. So understanding what is set theory, what are sets, what is union of sets, what is intersection of sets, all of that is very important, as well as Venn diagrams. So you should be able to draw Venn diagrams and find out what is A union B, A intersection B. All of that is also something that you should know for cracking quant in the GMAT exam. Related to this is also the topic of discrete probability and counting method. So basically your permutations and combinations, so that is P and C, and counting the number of ways in something can be done, counting the number of ways of selecting things, counting the number of ways of arranging things, and probability based on this. So for example, if you are asked if you have 5 colors and you have 3 tiles to color, in how many ways can you color the tiles differently? So here you are counting the number of ways in which you can color, and discrete probability based on this would be basically probability that one of the tiles would be red in color. So essentially probability based on counting. It's discrete probability because you have discrete number of events or satisfying this particular condition and a discrete sample space. So because of that, you have to have, before you go to this, you should have a good idea of set theory and of counting methods, that is permutations and combinations, and then you can solve questions based on probability as well, which is based on both set theory as well as counting methods. So this is basically what is going to be included in the arithmetic topic. So now that you have some idea, let's take a look at a few questions that can actually come from this particular topic, so that you have a better idea of what kind of questions come and how to solve them. So the first question is, if a fraction p by q and p and q are co-prime and greater than 1 is modified in a way that a certain positive integer is added to both the numerator and denominator, the value changes to 5 by 3. What is the minimum possible value of p plus q? So over here we are given some information about p and q, that p and q are co-prime. So what are co-prime numbers? Co-prime numbers are numbers whose highest common factor is 1. So highest common factor of p and q is 1, which basically means that they have no factor in common. So for example, 2 and 5 are co-prime to each other because there is no common factor. HCF of 2 and 5 is equal to 1. But it doesn't mean that individually they are prime numbers. So for example, 2 and 25 are also co-prime numbers because their highest common factor is also 1. Even say HCF of say 6 and 25, both numbers are not prime numbers, but they are co-prime to each other because they do not have any factor in common. The factors of 6 are 1, 2, 3 and 6, and that of 25 are 1, 5 and 25. So the highest common factor between them is 1, which means that they have no common factor other than 1 common to them, which means that their highest common factor is 1. So they are co-prime to each other. So in this case, p and q are co-prime to each other and are greater than 1. So that is what we know. Then we have the other information that is given is that a positive integer is added to both numerator and denominator and the value changes to 5 by 3. So let's say the positive integer, let it be a. So you have p plus a divided by q plus a, is this ratio is equal to 5 by 3. So 3p plus 3a is equal to 5q plus 5a. So this means that 3p is equal to 5q plus 2a. Now a has to be, what is the condition? We have to find out the least possible value of p plus q. So if you have to find out the least possible value of p plus q, we should find the least possible value of p and q. Since p is linearly related to q, as q rises, p is also going to rise because this is a linear equation. They are not inversely related. So essentially, if I try to minimize the value of q, the value of p will minimize. That would mean that p plus q will minimize. So I have to find out the least possible value of either p or q such that it satisfies this equation, given that a is a positive integer, so a has to be greater than or equal to 1 and a is a integer. Then you have that p and q are co-prime to each other and are greater than 1. So p, q are greater than 1 and are co-prime. So as long as these conditions are met, if the least value I get of either p or q such that this condition is met would be the right answer. Now if you consider the equation, right, okay, this is 5q plus 2a. Now consider if p is even, what can we say about q? If p is even, this is 2 times a, so this will also be even. So this is even, so that would mean that q is also even in that case, right? Because then if p is even, p will be equal to sum of even plus even, this is even. So q would also have to be even if p is even. But if p and q are both even numbers and greater than 1, what would that mean? It would mean that they cannot be co-prime, which would mean that the condition is not met. So p cannot be even, p has to be an odd number. And if p has to be an odd number, q also has to be an odd number. Otherwise, even plus even will have to give you an even number, which means that p is odd and q is odd. So now that we understand that p is an odd number and q is an odd number, let's try to see what values of odd numbers greater than 1 satisfy this particular condition such that they are co-prime to each other. So the first odd number greater than 1 that I can think of is q is equal to 3. In this case, let us say a is greater than or equal to 1. So let's say a is equal to 1. If q is equal to 3, a is equal to 1, what do I get? 15 plus 2, 17. 17 is not a multiple of 3, so I cannot consider that. So this does not give me any integral value of p. Again, p and q have to be integers or other whole have to be natural numbers. They have to be natural numbers because a, they are co-prime, and that is just they are in the form of a fraction. So if they are in the form of a fraction and each is greater than 1, they have to be natural numbers. Okay, so q is equal to 3 and a is equal to 1. P, I do not get a natural number value for p. So let us consider a is equal to 2 in that case. In that case, this is 15 plus 4, 19. Again, no natural number value is equal to 3. How much do I get? 15 plus 6, 21. So in that case, p is equal to 7. Okay, so I get P is equal to 7, Q is equal to 3, A is equal to 3. Then is this condition satisfied? This is 7 into 3 is 21. This is 15 plus 6, that is 21. Are the other conditions satisfied? So you would have 7 by 3. 7 and 3 are co-prime to each other. So the condition is satisfied. They are both greater than 1. Condition is satisfied. Modified that if I add certain values, so they basically add 3 to numerator and denominator plus 3 plus 3. So this becomes 10 by 6, so that is 5 by 3. What is the minimum possible value of Q? P plus Q. So the first value which we get which satisfies these conditions is basically P is equal to 7 and Q is equal to 3. So the least possible value of the sum is 7 plus 3, that is 10. So the right answer to this is option E, 10. Essentially after that, if I go to say Q is equal to 5, next odd number that I would get is Q is equal to 5. In that case, if I get 25 plus 2, that is 27. In that case, P will be equal to 9. 9 by 5 would also be co-prime, but in that case, it won't be the least possible value because here it will become 14, while here 10 is possible. Okay, so that means that the lowest possible sum of P plus Q is 10. That's option E. Let's take a look at another question. This is based on descriptive statistics. So the question that is asked is, what is the median of 24, 43, 17, 29, X, 33 and Y? X and Y are natural numbers, and this is a data sufficiency question. So we are given two statements. Statement 1 is X plus Y is equal to 57. Statement 2 is X is less than 24. See, in this case, basically, I can immediately rule out answering the question from using statement 2 alone. How do I know what is the median of the set? See, basically, if I am able to place the median in this particular or in a given order, so that I can at least tell where the elements of the set will be, then I can find out the median without knowing the actual value of X and Y. So, for example, if I know that X 24, I'll first arrange the remaining elements. So you have 17, 24, 29, 33 and 43, and you have X and Y. So if I can see that it is X, Y are both less than 17, then 24, then 29, then 33 and then 43. I can say that this two, then 24 is the median of the set. If I can place X and Y with respect to the existing elements of the set, then I can figure out what is the median of the set without knowing X and Y. It is given that they are natural numbers. So that is basically the idea behind how much information is needed for us to actually answer this question. I need to be able to place X and Y with respect to the other elements of the set. Now, if I just consider statement 2 alone, I am not going in order, but I want you to also develop this instinct about what information is enough. If I consider only statement 2, I get some information about X, okay. So either X will be over here or it will be over here as such. Either it is between 17 to 24 or it is less than 17. In either case, I don't know where Y is, and then based on the position of Y, the median will change. If Y is greater than 43, it will be one value. If Y is less than 17, it would be a different value. So just knowing the value of X will definitely not be sufficient to find out the median of this particular set. Now let me figure out if statement 1 alone is enough. See, if X plus Y is 57, what does it tell? And X and Y are natural numbers. That would mean that X plus Y is 57. 57 by 2 is how much? That is 28.5. 28.5, which means that X and Y, X plus Y, the average of it is around 28.5. So that would mean that one of X and Y is greater than 28.5. So it is greater than or equal to 29, and one of X and Y is less than 29. So less than 28.5, so less than or equal to 28. So one of X and Y is greater than or equal to 29 and the other is less than or equal to 28. So for example, if X is say 28, Y will be equal to 29. If X is say 27, Y will be equal to 30. And say X is equal to say 1, then Y will be equal to 56, because there is a linear relationship between them. Now based on this, what can you actually tell about the position of X and Y with respect to the other elements that are there? See, over here, these are the other elements. So I'll just erase it a bit. So the other elements are 17, 24, 29, 33, 30 and 43. So in this case, I see that Consider 1 in 56. In that case, it would be over here and it would be over here. So they would be on either side of the elements, and 29 would be the median in that case. Now consider 27 and 30. Again, they would be either side of 29 and still the median would be 29. If it is any value, x is any value from 1 to 27, the median would still be 29 because the value of x would be over here and the value of y would be over here and the median would be unchanged. I am saying x is the lower value and y is the higher value, but even if I say y is the lower value and x is the higher value, it will not make a difference to what the median is, because the median will be the number that is between that which lies in the bang in the middle of the set. So as long as x and y are on opposite sides of the median, they balance each other out and the median remains 29. The only case where we can actually have to consider is the median still 29 is when x is equal to 28 and y is equal to 29. In that case, what do I get? I get 1, 17, 24, 28, 29, 29, 33, 43, 56. Even in this case, this is 4, this is 4, the median still remains 29. So no matter what the values of x and y, the median in all cases is 29. So can I find out the median of x of this given set given that given statement 1 alone? Yes, I can find out the median of the set is 29 using statement 1 alone, but statement 2 alone is not enough. So the answer can be found by using statement 1 alone, but not by 2 alone. So the right answer or right option is option A. In this case, I don't even give the options, but you should memorize the options. First is using statement 1 alone, second is but not statement 2 alone, second is using statement 2 alone but not statement 1 alone, third is not using only after using both the statements can you reach an answer, fourth is using each of the statements alone is enough, and fifth is using both of them together is not enough. So the right answer in this particular case is option A. Now let's consider the next question. So this is based on discrete probability. It is also requires you to do counting. So here the question is, what is the probability of getting head in the throw of a biased coin? So suppose you have a biased coin. In an unbiased coin, that is a perfectly fair coin, the probability of getting a head will be equal to the probability of getting a tail, which is equal to half. That is, there is a half chance that you will get a head or half chance that you will get a tail. So each probability would be exactly half in the case of a unbiased coin or a fair coin. In this case, it is given that the coin is a biased coin. So we don't know the values of H and T as such. And we are asked what is the probability of getting a head in the throw of a biased coin. So we have to find out the value of H. Now there are two statements that are given. The first statement is the probability of getting 3 heads in 3 throws is equal to the probability of getting 2 heads in 3 throws of the coin. So essentially, how can you get 3 heads in 3 throws? That is, if you get head into the probability of getting 1 head is H, of getting 2 heads in a row is H into H, of getting 3 heads in a row is H into H into H. That is, basically you have to multiply probability each time the event occurs. What is the probability of getting 2 heads in 3 throws? So if you get 2 heads in 3 throws, you can either get head, head and tail, or you can get head, tail and head, or you can get tail, head and head. These are the 3 ways in which you can get 2 heads in 3 throws. So in each of these cases, what is the probability? This is H into H into T. This is H into T into H, where H is the probability of getting a head, T is the probability of getting a tail, and H is the probability of getting a head. And this is equal to T into H into H. So this will mean that H into H into H is equal to, if I sum all of these up, I will get 3 into H into T. So from this I can cancel out, all of these will be non-zero, these will be essentially H will be, we know that H is equal to, H plus T is equal to 1 because it is a coin as such. There are only 2 sides to a coin. So the probability of getting a head plus the probability of getting a tail is equal to 1. So that is the sum of all probabilities. So H plus T is equal to 1, which means that this is an equation we know based on the fact that it is a coin. And from the first statement alone, from statement 1 alone, we get the additional information. I'll cancel 2 H's. So I get the additional information that H is equal to 3T. Now if I put a value over here, I can get the value of H as well as T. So using statement 1 alone, I can answer the question, what is the value of H? Now consider using statement 2 alone. If I use the statement 2 alone, I get the probability of getting 3 heads in 3 throws is equal to the probability of getting 3 tails in 3 throws of the coin. So in this case, h into h into h is equal to t into t into t, which would mean that h is equal to t, that is, it is an unbiased coin, so each of them should be equal to half. H plus t is equal to 1 because it is still a coin. So using statement t alone also, statement 2 alone also, I can answer the question is what is the value of h. So using each statement 1 and 2 alone, I can find out the answer to the given question. The question answer is different across the two statements, but I can answer the question using each statement alone. So the right answer, right option for this particular question is D. Each statement alone is sufficient to answer the question. Now that you understand what is there in arithmetic, let's take a look at the second most important topic when it comes to quant section of GMAT, that's algebra. So in algebra, you have your you have to solve equations in x, y, or any particular polynomial equation to get the answer as such. The most basic form of equations that you will get are linear equations. Linear equations are equations where you have variables x, y, and z, where the highest exponent of any variable is 1. So if you have x plus y plus z is equal to some constant, say 10, then this is a linear equation. The moment you have, if you have x, y, or you have x square or something like that, it becomes a polynomial equation and no longer linear equation. For linear equations, you need you need the highest exponent of any variable in this particular equation to be equal to 1. Now you have, in this you have a subpart which is special linear equation. So what are special linear equations? Special linear equations are equations where you can find out a answer or a subpart of the answer without actually solving the entire linear equations out. See, generally when you have linear equations of this sort, say x plus y plus z is equal to 10 and say 2x plus y minus z is equal to 8. And say another equation 3x plus 2y minus z is equal to 12. What you see is that you need 3 variables and 3 equations. If you have 3 variables and 3 equations, you can find out the value of x, y, and z. There are certain conditions in which case you won't be able to find out the equation. For example, if x, like the constants of or the what do you say, the if the coefficients of x, y, and z are equal across or in the same proportion across two equations, then you won't be able to find a unique answer, or you might find a there might be no answer as well if there are inconsistent equations. But generally, in most cases, if you have 3 equations and 3 variables, 90% of the time you will be able to find a unique value of x, y, and z. But essentially, if you have like x plus y plus z is equal to 10 and 2x plus 2y plus 2z is equal to 20, that is basically the same equation multiplied by 2. In that case, you do not have an additional equation as such. So in that case, you won't be able to solve those equations to get a unique answer. So in those kind of situations, you won't have a unique answer. In most cases, for 3 variables, for n variables, you will need n equations, n distinct equations as such. But at times you don't need n distinct equations, so that is where special linear equations comes in. So in certain kind of linear equations questions, for example in data sufficiency, if you are asked to find out the value of say x plus y, given that 2 equations are given with 3 variables. Now you might think that if 2 equations are given with 3 variables, I cannot find out the value of some subpart of the equation, or I don't know I can't find out the value of x and I can't find out the value of y, so I can't answer x plus y, and then you will mark that the equation or the information is not sufficient. But in special linear equations, you basically can manipulate the equations in such a way that you still answer the question that is given. So for example, if you say that x plus y plus 3z is equal to 100 and say 2x plus 2y plus 9z is equal to 250. Now, if you have something of this sort, you have 2 equations with 3 variables and you are supposed asked what is x plus y. Then you would be tempted to say that I have 2 equations with 3 variables, I cannot find out what is the x value of x, y, or z, and therefore I cannot find out the value of x plus y. But if you take a look at the equations as such, you see that x plus y have the same coefficient in both equations. So let's say that x plus y is equal to a, then you have a plus 3z is equal to 100, and you have 2a plus 9z is equal to 250. Now you have to basically find out the value of A, and in this case you have two equations, two variables, you will be able to find out the value of A. So using information like this, special linear equations are essentially linear equations where by using external conditions or by using certain or manipulating the condition equations in some way, you can actually arrive at the desired answer even though you do not have technically you do not have enough information to arrive at a unique solution. So that basically comes under special linear equations. These are especially important for data sufficiency. So that is the first thing that you should know. Also you need linear equations with conditions. So for example, if it is given, for example, the 3x plus 5y is equal to 18 as such. Now if something of this sort is given, and these are linear equations with special conditions, and you are told that x and y are positive integers. Now if x and y are positive integers, there are very few values of x and y which would actually satisfy something like this. If x and y are positive integers, I can say immediately that y has to be a multiple of 3. So that would mean that y can take the value of 3 or 6 or 9 of something like this. But if y takes the value of 6, then x becomes 0. Y takes the value of 6, then x becomes negative. So the only value that x and y can essentially take is y is equal to 3 and x is equal to 1. If it is given, the extra condition is given that x and y are positive integers. So though I have only one equation with two variables, by using the external other conditions that are given, I can come at an actual unique solution as such. So these are another subpart where you have linear equations with special conditions which also come as part of data sufficiency. So linear equations in general are super important as far as data sufficiency is concerned, and as far as finding the answers in data sufficiency is concerned. The second part of algebra is quadratic equations. So quadratic equations are essentially equations where the highest exponent of the variable of the equation is 2. So for example, ax square plus bx plus c is the standard form of a quadratic equation. It's a quadratic equation because the highest exponent of any particular variable over here is 2. So this is a quadratic equation. In general, if it is nothing of this sort, you have any kind of equation where you'd say x, there are two variables x and y and they are multiplied together, or they have indices higher than 2, then it's called as a polynomial equation. So for example, ax cube plus by square plus cxy plus z equal to 0, this would be a polynomial equation. So these are the basic equations or parts of algebra you need to know. Also you should know you have an understanding of exponents. So what is ax cube? So this is essentially a raised to x raised to 3, where 3 is the exponent. This is the basic understanding of what equations are, what exponents are, what the base of the exponent is. That is fundamental knowledge when it comes to algebra. So these are the three parts that you should know very well. Apart from this, you would need to know something which is called as inequalities. So 2 I put as quad and polynomials, 3 would be inequalities. So inequalities can be any equation essentially where instead of the equality sign you have a inequality sign. So instead of saying say x plus y plus z is equal to 10, you replace this equality sign with say less than or equal to. X plus y is equal to less than or equal to 10. So in this case you get a inequality. There are enough questions that come on inequalities as well. When it comes to algebra, you should have a graph view of equations as well. So if you have like say linear equation x plus y is equal to 1, that is a line. So if you have a linear equation of the form with two variables x plus y is equal to 1, that is the equation of a line. Equation is the equation of a line and inequality is the equation of an area. So if you have x plus y is less than 1, it would essentially be the area below the line. So if you have to think of it instinctively, just know that linear equations with two variables are the equations of a line. Linear equations with linear inequalities with two variables are the equations or the represent an area. If you have a 3D plane x plus y plus z, then a linear equation would be the equation or would represent a plane. So x plus y plus z is equal to 10 represents a plane in the 3D space. A plane is basically, think of it like a sheet of paper. A sheet of paper in the 3D space would be a linear equation. An inequality would be a volume. So if you have a sheet of paper, all the volume that is trapped below the sheet of paper would become an inequality. So that is the relationship between linear equations and inequalities. You will have to understand both of them and how to use each of them to actually solve for either in data sufficiency as well as in problem solving. Now based on this, you have functions and graphs. Functions are basically where instead of giving the equation directly and equating it to 0, you say that, let's say that function f of x is equal to ax square plus bx plus c. So this, in this case, f of x is a function over here. Now if functions and graphs, it might come as where you have polynomial equations which you either have to factorize or manipulate to get to the answer, or you can get functions and graphs basically just to draw the functions and figure out how many roots are there for a given function, what is the value of the function at different points of time. So for when x is equal to 5, what is f of x? So all of these are questions that can come under functions. Another important function, modulus, is a function. So modulus is the absolute value function. It is defined as this. So modulus of x basically means that if x is a positive integer, if x is greater than or equal to 0, it is equal to x. If x is less than 0, then modulus of x is basically minus x. So what is modulus of minus 2? Modulus of minus 2 is 2. Modulus of 2 is also 2. So essentially modulus function is also called as the absolute value function, where you just take the absolute value of a number, you discard the sign and take the absolute value. So if there is a negative sign, you just remove the sign and you get the absolute value of the particular particular variable or a constant as such. So that is the modulus function, and a lot of questions come on the modulus function as well. Apart from that, you have questions on surds and indices. Surds are basically composite numbers which have irrational and rational parts. So for example, a plus root b, a minus root b are surds if b is not a perfect square. If b is not a perfect square, then root of b would be a irrational number. So any number which is the sum of a rational plus irrational number would be called as a surd. So they generally come in pairs, because when you multiply them together, you get a square minus b. So you often have either like say square roots of a quadratic equation, or in any of those kind of scenarios, the surds appear in together as such. Indices is the opposite of this. This is basically b raised to n is the indice as such. Basically b raised to any power such that it is greater than it's a rational number would be n here would be the index of that number. So both of these come in as part of algebra. And the last question, or last type of question that come are linear programming questions. Linear programming is basically maximization and minimization questions. So you will be given certain linear equations which represent either what function you have to maximize or minimize, or you will be given certain restraints. So for example, I will just give you a basic example. So suppose that you are given that suppose there are two products that you can actually produce in a factory, product A and B. The profit of from selling product A is say rupees 10. So this is profit, and say profit from selling product B is say rupees 5, and the number of work hours required to produce product A is say 8 hours, and say from B is say 3 hours. So you have basically certain idea of how much cost is there, how many work hours are there, and how much profit can be derived from each of them. So you can say that okay, you have to produce say 50 units of A. So the number of units of A is n of A, say has to be greater than or equal to 50, n of B has to be greater than or equal to say 20, and based on these conditions you have to find out what is the maximum profit that you can make. So you have to say that okay, profit per unit is 10, profit per unit is here is 5, so 10 times NA plus 5 times NB would be your profit, and if I have to maximize the profit, I have to maximize this particular equation. So that is the essential idea behind linear programming. We'll take a good look into it later on, but that is essentially linear programming, where you have to maximize certain thing or minimize certain thing using linear equations. It is basically linear equations, drawing graphs, and by using graphs you have to solve for the max possible value or min possible value. That's it. There's nothing much to it. So these are the different types that come as part of algebra. So now that you have a good idea of what comes in algebra, let's take a look at a few questions. What is the cost of 14 apples and 19 mangoes? So here you have to calculate, suppose let's say the variable representing the cost of apple is say A and this is say M. So I have to find out what is 14A plus 19M. Okay, that is a question. I should be able to find out this value. So statement 1 is 2 apples for plus 5 mangoes is cost 150 rupees. So 2A plus 5M is equal to 150. Now from this, can I find out this? If I multiply by 7, I just get this as 14A plus 35M is equal to 7 times this. So this would be 1050. But this does not give me 14A plus 19M, which is what I want. So by using statement 1 alone, I cannot find out the required answer. Now consider statement 2 alone. So I'll ignore statement 1, I'll go to statement 2 alone. 10 apples plus 25 mangoes cost the same as 8 apples plus 30 mangoes. So 10A plus 25M is equal to 8A plus 30M. Now using this equation alone, I say that 2A is equal to 5M, or rather A is equal to 5 by 2 times M. Now if I plug it in this particular equation, I get some equation with either A or M, but I will not be able to eliminate the variables entirely. So by using equation 2 alone also, I get a relationship between the variables, but I do not get an absolute value. Now if I use both statements together, so if you use both statements together, this is a linear equation in A and M, this is a linear equation in A and M, this you can write it as 2A minus 5M is equal to 0. So if you have two linear equations with two variables, most of the time we will be able to find out the value of A and M. And if I know the value of A and M, then I can answer this particular question. Generally in this case, you just have to check that the coefficients are not identical. See, essentially in if you have two equations with two variables, the only time when you won't be able to find a unique solution is if the coefficient of this divided by coefficient of this and is equal to the coefficient of the first equation divided by the coefficient of the second equation. If 14 by 2 is equal to 35 by 5, then you will, this is minus 5. So that's why it's not this. If 14 by 2 is equal to 35 by minus 5, then you won't be able to find a unique solution, because then it would just be a multiple of this equation. But if it is not the same, so in this case, if you had this in this equation, you won't be able to find any solution, because they would be essentially the same equations. So if that is the case, then you will have zero solution. But in this case, because it is minus 5, these two are not same, and you will find a unique solution as such. So in this case, I will be able to find a unique solution. I need not actually calculate what is 14A plus 19M. I know for sure based on this information that I can calculate the value of A, I can calculate the value of M, and using both equations together, I can calculate what is 14A plus 19M. The only thing is that once you get two equations with two variables, you have to check, is this by this, the coefficient of A in the first equation divided by coefficient of A in the second equation, and the coefficient of B in the second variable in first equation divided by coefficient of B in second equation. If that ratios are same, then it's the same, like essentially it's a multiple of the same equation, and then you cannot use it to find out a unique solution. If that is ever the case, then you can directly ignore that and say that both of them together are not enough to answer the question, and then the correct option would have been E. In this case, since both together are sufficient to find out the answer, I would say the right answer is option C. Both of them together are sufficient to answer, but each of them alone is not sufficient to answer. I'm not actually going to calculate the answer because it's not needed. So always remember, just do this check when you have linear equations. Don't actually bother finding out the actual answer. If the linear equation coefficients ratio check passes, then you need not actually go ahead and find out the answer as such. Now let's take a look at the next question. What is the value of the quadratic expression at f of x at x equal to minus 5? So you have to basically find out what is f of minus 5. So first statement is the sum of the roots of the equation f of x is equal to 0 is the same as that of the equation x square minus 8x plus 7 is equal to 0. So what is f of x? F of x would be of the form, it's a quadratic equation, so it will have two roots. So it will be some constant into x minus alpha into x minus beta, where alpha and beta are the two roots of the equation. Okay, so in this case I am given that the sum of the roots of this equation are the same as that of equation this. So I know that alpha plus beta, see the sum of roots of a quadratic equation is this coefficient minus this coefficient by the coefficient of this. So alpha plus beta will be equal to 8 according to statement 1, that is the sum of the two roots will be equal to 8. Statement 2 is the difference between the roots of equation f of x is the same as that of this equation. So that is x square plus 25x plus 100 is equal to 0. So this is from statement 1 alone. From if I know alpha plus beta, I cannot find out the equation f of x just by knowing alpha and beta. I also need a as such. And alpha and beta, again I don't have the individual values, so I can't find out what is f of x. Now using statement 2 alone, what will I get? This would be difference of the root. So I'll get alpha and beta. So if I factorize this, this is basically x plus 20 into x plus 5 is equal to 0. So the roots are minus 5 and minus 20. So the difference between the two roots is minus 15. So essentially difference is 15 as such, because it is essentially the positive difference is indicated. So minus 5 minus of minus 20 is 15. So alpha minus beta, that is the modulus of this, will be equal to 15. The difference of the roots will be equal to 15. Now using both of these two statements alone, can I find out what is the value of this? See, essentially if I even say that let alpha be the higher root, because it doesn't make any difference whether alpha is over here, beta is over here, even if the roots get swapped, it doesn't make any difference. So even if I say that let alpha be the higher root, it won't make any difference as such. I'll get the value of alpha and beta by you solving these equations. But even if I get the value of alpha and beta, I don't know the I don't have any information about this particular coefficient a. So even by using both of these statements together, I do not know what is the actual f of x as such. And if I do not know what is the actual f of x, I cannot find out what is f of x at x equal to minus 5. The only way I can actually know what is f of x at x equal to minus 5 is if minus 5 is one of the roots. So that I will check. In this case, I get 2 alpha is equal to 23, alpha is equal to 23 by 2, beta will be equal to minus this minus 7 by 2. So this would be, neither of it is minus 5, so it is not going to be 0. So if it's not going to be 0, I do not know what it will be at f equal to minus 5. So using both of the statements together also, I cannot answer what is f of minus 5. So the answer to this question is D, sorry, not D, E. Both of these equation statements taken together also do not help me find out what is f of x. And if I do not know what is f of x, I cannot say what is f of minus 5, because I know that x equal to minus 5 is not one of the roots. Okay, so this is basically how you should actually go about solving it. Find out the implication or the meaning of the first statement. From that can I answer? No, I can't answer. Use the second statement. From that can I answer? No, I cannot answer. Using both of them together, I can get the value of the roots, but using the roots alone, I do not have the value of the coefficient as such. Without the coefficient, and since the roots are not, minus 5 is not one of the roots, I cannot find the value of f of x at x equal to minus 5. So this is basically how you should solve questions based on algebra. Let's take a look at another question. So this is based on indices. So consider the following question. We have 45 raised to a into 20 raised to b is equal to 6 raised to c into 30 raised to d. So you have, if you try to factorize each of these, what is 45? 45 is essentially 9 into 5. So 9 is essentially 3 square into 5. 20, so I am prime factorizing each number. 20 is essentially 2 square into 5, that is 4 into 5. 6 is equal to 2 into 3, and 30 is equal to 2 into 3 into 5. Now by using this equation, we have to find out, is this equal? So there is a question mark over here. 45 raised to a is essentially 3 raised to 2a into 5 raised to a into 20 raised to b, so that would be 2 raised to 2b into 5 raised to b is equal to, is it equal to question mark, I will put 6 raised to c, that is 2 raised to c into 3 raised to c into 2 raised to d into 3 raised to d into 5 raised to d. Now when you have exponents like this, you can essentially club them together. So I can say that the left hand side is equal to 2 raised to 2b into 3 raised to 2a into 5 raised to a plus b. Is this equal to 2 raised to c plus d into 3 raised to c plus d into 5 raised to d. So when would this be equal? For this to be equal, firstly a plus b will have to be equal to d, where the exponent or index of 5 in the left hand side is equal to the index of 5 on the right hand side. Secondly, 2b will be equal to c plus d, and thirdly 2a will be equal to 2a will be equal to c plus d. So if all of these can be inferred by using the statements, then I can say that these two are equal. If all statements, 3 statements, I can determine to be true by using one of the statements alone or second statement alone or both of them together, then I can say that this question can be answered. So consider the first statement alone, c is equal to 0. If c is equal to 0, then I get that d is equal to 2b. I don't know whether d is equal to 2b, but essentially c is equal to 0. Then I have to say that is a plus b equal to d? I can't answer. In that case, is d equal to 2b? Again, I can't answer. Is d equal to 2a? I can't answer. So using just this statement alone, c is equal to 0, I essentially cannot ascertain whether the truth value of any of these 3 statements as such. Now consider if statement 2 is true, that is d is equal to d minus a is equal to b. So that would mean that d is equal to a plus b. Then this condition becomes true. But in that case also, does the second condition become true? No. You don't know the value of c, you don't know the value of a as such. Individually you don't know, you know a plus b is equal to d, but individually you don't know whether they are equal as such. So again, these cannot be answered. The remaining 2 equations cannot be determined to be true using statement 2 alone. Now using both of them together, if both of them are considered together, then this is true. D is equal to a plus b, c is equal to 0. In that case, we will have to figure out is d is equal to 2b and d is equal to 2a. I know that d is equal to a plus b, but I need to know whether a and b are equal. Only then I can actually figure out whether these are true or not. So statement 2 and 3 I still cannot figure out even with using both the statements together. So even using both the statements together, I cannot determine if left hand side is equal to right hand side. So because I cannot determine if left hand side is equal to right hand side, I cannot answer the question, and that means that using both of the statements together also I cannot answer the question. So the right option to choose is option E. I cannot answer the question using both of the statements together. So this is basically the information that you need for algebra and arithmetic. Now the third most important topic is geometry. So in geometry you would essentially have, we'll start from the very basics. So in 2D figures, what do you need? You need an understanding of coordinate geometry. What is a 2D plane? What are equations of line? This comes from algebra also. It helps a lot in algebra also if you are able to draw lines or graphs representing functions. So you need an understanding of coordinate geometry. But apart from the coordinate plane, you should have the understanding of what are lines and intersecting lines and angles that are produced by intersecting lines. So essentially, if there are 2 parallel lines and a transversal, what are the angles produced? There are corresponding angles, opposite angles, all of those are essentially things that you should know. Lines, intersecting lines and angles are basically the most basic understanding of geometry. Parallel lines, non-parallel lines, intersecting lines, transversals, the angles produced by each of these things, all of that is super fundamental to understanding anything in geometry. After that, if you understand that, you need to have a good understanding of triangles. So triangles, consider all parts of triangles. What are the conditions for a triangle to be formed? So what are if ABC are the sides of a triangle, what are the limiting conditions on the sides of a triangle? What would be the interior angles, sum of interior angles, all of the basic properties of triangles, theorems related to triangles, parts of triangles such as incenter, centroid, orthocenter, median, the altitude, all of the basic terminology associated with triangles you should be very, very thorough with. So apart from triangles, after triangles, you should also have a very good idea of circles. What are chords, what are tangents, what are theorems related to circles, how many places, or how can chords intersect, how can tangents intersect, if there are two overlapping circles or two circles which touch each other externally. So all those kind of situations you should be able to solve in for GMAT as such. So circles you should be thorough with. Apart from that, you need to know polygons and quadrilaterals. So especially regular polygons and regular quadrilaterals. So quadrilaterals you should know are like squares, rectangles, trapezium, trapezoid, parallelogram, rhombus. All of these are different types of quadrilaterals. You should know exactly the definition of each quadrilateral and the properties of the same. Apart from that, if you come to polygons, basically pentagon and hexagon, you should know what are regular polygons, what is the formula for the exterior angle of a regular polygon, if you have what are the different names of the regular polygons, and what is the how to calculate a area of a given regular polygon. Especially you need not know for a nonagon or something like that, but you should know for a hexagon. So what would be the area of a hexagon, you should be able to calculate. So this is for polygons and quadrilaterals. We will be covering all of them in detail, but I want you to know that this is part of the portion. Okay. Apart from that, we will have to come to the last part, which is solids and mensuration of solids. So essentially a cylinder, then you have cones, you have spheres, all the solids basically you should be able to find out what is their curved surface area and volume. So similarly for triangles and circles, area formula, area, perimeter, all the mensuration part is super important. Similarly for solids, the volume and surface area questions are generally asked. So volume also you will have questions where one thing is melted to form the other or something of that type, and you should be able to answer questions of that type. Okay, so these are the basic things that you should know when it comes to geometry. Geometry is a vast topic. There are a lot of formulas there, and it will take some time to cover all the formulas, but you should know that these are the topics that you have to cover when it comes to geometry. Now let's take a look at a few questions from geometry so that we understand what is exactly asked, how the questions are asked. So consider the following question. What is the sum of all the interior angles, internal angles of a regular polygon S? So you don't know what that regular polygon S is. Is it a hexagon? Is it a pentagon? So that is not given. We have to find out the sum of all internal angles of a regular polygon. So what is the formula for the internal angles of a regular polygon? See, if you have any regular polygon, say consider a hexagon or anything of that sort, the general formula that you have to remember is that the external angle would be 360 by n, where n represents the number of sides of that regular polygon. So if n is equal to 5, it's a pentagon, then it would be 360 by 5, that is 72 degrees. So in that case, the external angle will be 72. So what would be the internal angle in that case? That would be 180 minus 360 by n. So the each internal angle of the regular polygon would be 180 minus 360 by n. So what would be the sum of all internal angles? That would be n times that. So that would be essentially n times 180 minus 360 by n. So this would be basically 180 n minus 360 as such. So if you have any information either related to the external angle or n as such, if you know what is the number of sides, you can calculate what is the sum of interior angles. If you can figure out any of the things which essentially give you the value of n, you can find out the value of sum of all interior angles. So consider statement 1 alone. So statement 1 alone is each side of the polygon has length of 8 centimeters. Now using the length, can I figure out what is the number of sides of the polygon? No, because I can form a pentagon of side 8 centimeters. So this is 8 centimeters. Similarly, I can form a hexagon of side 8 centimeters. So again, this would be 8 centimeters. Just knowing 8 centimeters does not give me any idea of n, because it is not unique to the idea this of n. There can be pentagons of side 8 centimeter. There can be hexagons of side 8 centimeter. There can be any n-sided figure of side 8 centimeter. So the length of the side gives me zero information of how many sides are there in that particular regular polygon. Now consider, so this alone does not help me solve this question. Statement 2 is exterior angle of the polygon is 40 degrees. So what is exterior angle? Exterior angle is 360 by n, and second statement tells me that 360 by n is equal to 40. What does this mean? This means n is equal to 9. If I have n is equal to 9, I can substitute it over here and find out the sum of all interior angles. So by using statement 2 alone, I can find out the answer to the given question. So the correct option to choose is option B. By using statement 2 alone, I can answer the given question. So the answer is option B. So let's take a look at the next question. So this question is on a data sufficiency question on circles. So consider the question, what is the area of the circle C1? So for an area of the circle, we know that area of the circle is equal to pi r square. To find out the area of a circle, we'll either need to know the radius, or in some way we have to be able to calculate the length of the radius. So if we know that, then we'll be able to calculate the area of the circle. So if any given circle, if I can find out the radius, I will know the area of the circle as such. So let's consider each of the statements individually. PQ is the longest chord of the circle with length 10 centimeters. So if you consider any circle, okay, this is a chord of the circle, which is basically any point, any line joining two points on the circumference of the circle. So what would be the length, longest chord of a circle? The longest chord of the circle will be basically when if you take any point, the furthest point from that any point on the circumference of the circle is the one which is diametrically opposite. That would be the furthest point. So the longest chord of the circle would be the diameter of the circle. So this means that the diameter of the circle is equal to 10 centimeters. So that means radius is half of diameter, that is 5 centimeter. So if I know the radius of the circle, I know the area of the circle, and based on that I can find out what is the area of the circle C1. So using statement 1 alone, I can answer the question that is there. Consider statement 2 alone. In this case, I ignore the information of statement 1. AM and RM are two intersecting chords of the circle of length 5 cm and 12 cm respectively. So AM and RM, they are two intersecting chords. They are have the common point M. So this, let's say this is AM, this is RM, and this is 5, this is 12. Okay. Now using this, can I figure out the area of the circle? See, if I don't know the included angle that is there between these two chords, I cannot determine the area of the circle, because suppose this is say 60 degrees, I will have one circle that passes through these 3 points. If it is say 30 degrees, okay, 5 and 12 like this, if it is 30 degrees, then there will be a completely different circle that will pass through those 3 points. So depending if I have this and the included angle, then I can figure out the triangle, and then I can find out the circumcircle, and then I will know the area of the circle. But if I don't know the included angle as such, the triangle AMR can be any triangle as such. It could be 60 degrees, 70 degrees, the entire triangle can change accordingly. Now if the triangle changes, the circumcircle will also change. So if the circumcircle changes, the area changes. So just based on the length of those two chords, I cannot uniquely determine the area of circle as such, and because I cannot uniquely determine the area circle, I cannot uniquely determine the area of the circle. Depending on what is the included angle, the triangle will change. As the triangle changes, if it becomes a very acute angle, it will be one circumcircle. If it is a very obtuse angle, it's a different circle, and the radius will also change based on that. So then the area will also change. So there is no, I cannot definitively answer what is the area of the circle using statement 2 alone. So in this statement 2 does not help me determine the answer, but statement 1 does. So the right option to choose is option A. Now consider the next question. There is a hollow cylinder of height h and diameter d. Is the volume of the largest cube that can be fit inside the smaller cylinder smaller than the volume of the largest cuboid that can be fit into it? So basically you have a cube. What is a cube? So if you know what is a dice, that's a cube. Basically it's a square in a 3D format. Each length of the edge of a cube is of the same length. So all of them would be S. So what is a square to a cube? The same relationship is between a rectangle to a cuboid. In a cuboid, it's a 3D solid with every face of the cuboid is a rectangle as such. So the length, breadth and height, length, breadth and height need not be equal. They can be different values as such. So that basically means that each face of a cube is a square, each face of a cuboid is a rectangle. But now you would know that every square is in fact a rectangle. A square is a rectangle with equal sides. So that would mean each cube is also a cuboid. Now in this case, if each cube is a cuboid, that would mean that if you remove all conditions, the largest cuboid, largest cube that can essentially be formed, that at max can be equal to the largest cuboid that can be fit into it. because essentially largest cube has additional restrictions that all height, length and breadth has to be same. But the largest cuboid does not have these restrictions. So if I say whether is it smaller than, the only way I can answer is that there are two cases. The volume of the cube can either be equal to the volume of the cuboid, or it can be less than the volume of the cuboid. It can't be greater, because the cube will always be less than or equal to the volume of the cuboid, because essentially cuboid, every cube is by default a cuboid. So if this cube can be fit in, then that won't be the largest cuboid that can be fit in essentially. So if you say that, okay, this is the volume of the cube, by default the volume of the cuboid would be less than, would be greater than or equal to this volume. So when would this be equal, when would it be lesser? You will have to basically just consider these conditions, and then based on that we can answer the question given the information. When will the volume of the cube, largest cube that can be fit into the cylinder, be equal to the volume of the largest cuboid that can be fit? See, consider the cylinder, okay, you have a cylinder like this, okay. So what is the volume of the largest cube that can be fit? That is basically, if you consider the circular cross section, the largest cube can be basically the, when you will inscribe the largest square inside the circle, and you have the height, same height as the largest square that can be inscribed, that would be the largest cube that can be fit. So that essentially is the largest cube that can be fit inside the cylinder. Now what would be the largest cuboid? Since if the height is greater, right, you still have the same square in the bottom, or you have any other this as such, you would, because it's a regular figure, it would still be a square at the bottom, but because the height is different, the largest cuboid would essentially be the tallest or the entire length of the cylinder as such. Okay, so that because of that, that would mean that if the height of the cylinder is greater than, if the height of the cylinder, if it is greater than the diameter by root 2, d by root 2. So this essentially means if this is the diameter, this is d by root 2, right? So each side of that square will be d by root 2. So that means that the height of the cuboid will also be d by root 2. So if the height of the cylinder is greater than d by root 2, that is diameter of the cylinder by root 2, then the volume of the cuboid would be greater than the volume of the cube, because then you can fit in a taller cuboid as such. If you consider what is a square you can inscribe into a circle, that would be, this is the diameter of the circle, so each side would be d by root 2, this is d by root 2. So the cube, the volume of the cube that, what is the largest cube that can be fit inside the cylinder would be of each side being d by root 2. Other than that, if the cylinder is in fact lesser than d by root 2, then the limiting condition is of the height. Then the tallest cube that you can fit is in fact a cube with all sides equal to h, if h is less than this. So in this case the cube again would be smaller as such, that you can fit. Then you would have a rectangle and a cuboid of height h as such. So in this case also the cube or the side of the cube is determined by which is lesser, h or d by root 2, and accordingly the side of the cuboid cube is fixed. Now for the cuboid, if height of the cylinder is more than d by root 2, what happens? If the height of the cylinder is more than d by root 2, then you can fit a long cylinder inside that long cuboid inside that cylinder. If height of the cylinder is less than d by root 2, what will you do? You will have a short cuboid, okay, you will have the height of the cylinder equal to the height of the cuboid, but in that case then you will no longer use the, you will not say that, okay, I will just use h over here. No, you will have h equal to the height equal to height of the cylinder, but the base will still be the largest square you can fit. So because of that, because it is a cuboid, your volume will be, if height of the cylinder is not equal to d by root 2, the volume of the cuboid will always be greater than the volume of the cube. So it will always be smaller, volume of the cube will always be smaller than the volume of the cuboid if height of the cylinder is not equal to d by root 2. When would it be equal? It would be equal when height is equal to d by root 2. So the only thing that you need to figure out is if the volume is smaller than the volume of the cuboid, is it h equal to d by root 2? So for that, what do you need? You need h and you need d by root 2. If you consider the statement 1 gives you h, statement 2 gives you d. Now using both statement 1 and 2 alone, I cannot actually determine whether h is equal to d by root 2, greater than d by root 2 or less than d by root 2. But if I use them, both of them together, I can evaluate which of these is true. which means that h is greater than d by root 2, which would mean the volume of the cuboid would be larger than the volume of the cube, and I will be able to answer the question. So in this case, by using both statements alone, I can answer the question. So the right answer to put is option C. So this is basically how you should think of it. Can I uniquely determine the answer? I don't need to actually answer the question, but can I uniquely determine the answer? What is the condition that I have to actually fulfill to answer the question? What information do I need to answer the question? In this case, I needed h and d together. So if I have h and d together, I can answer the question. So once I realized that, I knew that the answer would be option C. Now let's take a look at the question based on data sufficiency question based on coordinate geometry. So consider the question, is the y-intercept of a line greater than 0? So you have to find out what is the y-intercept of a line. So what is the y-intercept of a line? Y-intercept of a line is, suppose this is the line, y is equal to mx plus c. The y-intercept is the point at which it intersects the y-axis. So if the line is of this sort, it is a positive intercept. If it is of this sort, it is a negative intercept. Even with a positive, even with a negative slope, you can intersect it like this. Even with a positive slope, you can intersect it like this way. So depending on the slope and the x-intercept, you will be able to determine the value of the y-intercept. So let's consider the information that is given. The product of the slope and the x-intercept is negative. Now, what is x-intercept in this case? X-intercept is the point at which x-intercept is the point at which it intersects the x-axis. So, if x-intercept is product of x-intercept and this is negative, what does it mean? So, x-intercept say is xi, then that basically means y is equal to mxi plus c, where c is the y-intercept. And this is basically mxi basically means that the y value will be 0, that because it's a x-intercept. At when you intersect the x-axis, the y value or the y coordinate is 0. So 0 is equal to mxi plus c, which means that c is equal to minus m times xi, that is minus the product of slope and the x-intercept. But if it is given that the product of the slope and the x-intercept is negative, minus of that would be positive. So if using statement 1 alone, if this is the case, it is minus m times xi, I can infer that the y-intercept of the line will be greater than 0, because in this case c will be positive. This part is negative, minus of negative would be positive, so c would be positive and c is the y-intercept. So using statement 1 alone, I can answer the question. Now consider statement 2 alone. Sum of the slope and x-intercept is positive. Now using this, can I actually figure out whether the y-intercept is positive? This is c over here. I am given that m plus xi is positive. If using this, can I figure out the this as such? I can't, because I need the product, not the sum. Because essentially, if m is positive, say 6, and x is negative, let's say minus 3, the sum is greater than 0. And the product is also negative, and then c will be greater than 0. But if say m is minus 1 and suppose m is 2 and x is 3, so both are positive. In this case, the product is positive and the c intercept is negative. So just on the basis of the fact that m plus xi is positive, I cannot tell whether c is positive or c is negative. So based on statement 2 alone, I cannot determine whether c, or that is the y-intercept, is greater than 0. So using statement 1 alone, I can figure out the sign of the y-intercept, but using statement 2 alone, I cannot figure out the sign of the y-intercept. So is it greater than 0? I can answer using statement 1 alone, but not the statement 2 alone. So the right answer is option A. Now the last type that you have to remember is word problems. In word problems, basically you have all the quant problems which you have a paragraph given, and based on the paragraph you have to solve to get to the answer. So you will have questions based on profit and loss, and you have questions based on interest, simple interest, compound interest, etc. from mixtures and solutions. You have time and work. Basically, this many people take this much time to do some work. A takes 10 days to do a work, B takes 20 days to do a work. How much time would both of them together take to do the work? So that's time and work. Mixtures and solution is that you have one solution which is 10% concentrate, another solution which is 20% concentrate, in what ratio should they be mixed to get something which is 17% concentrate. So something like that would be mixtures and solution. If you think of it, it is mostly ratio and proportion question as such. This would be, you can consider it as something where you can, you have to write down linear equations, solve the linear equations to get at the answer. Similarly, profit and loss, you need to know the basic information of what is profit, what is loss, what is profit percentage, what is the mark price, cost price, selling price. If you know the terminology, you know the formulae, they are super easy questions. Then the slightly harder one comes with time, speed and distance. Here you need to know the time, speed and distance formulae. You need to know like different types of time, speed and distance concepts like relative velocity. Relative velocity will help, it's not absolutely necessary, but it will help in more complicated questions. So this would be slightly on the difficult side when it comes to this entire section as such. These are very formula based. This is very logical and mostly on the easier side. This is slightly on the harder side. Then apart from that, you will have questions which are based on data interpretation. Again, these are calculation based and understanding of graphs, understanding of charts, how to convert charts to tables, how to read graphs. It's just basically based on that. So again, it would be on the easier side, provided you know what are the different types of charts, how to read those charts. If you can do that, this would be a easy topic as such. So word problems on the whole generally are easier and less tricky as compared to data sufficiency questions. These are something that you should definitely score well in. So let's take a look at some of the questions from this topic. So consider this one. Tax is levied upon a particular good where the producer needs to pay the tax. The price after taxing is called tax price, which becomes the effective cost price. What is the profit percentage for the producer per each product? So we have to find out the profit percentage. So let's say that we have to find out P percentage, profit percentage. So what is profit percentage? Profit percentage is selling price minus cost price by cost price into 100. This is essentially the profit percentage. In this case, what is our cost price? Our cost price essentially becomes the tax price. The price after including tax is the effective cost price. So you have to say that what is profit percentage for us? It is selling price minus tax price divided by tax price into 100%. If we know what is the selling price and the tax price, or even if we know the ratio between selling price and tax price, we can answer this particular question. So if you get this ratio value, or if we know them individually, we can calculate what is P percent. So let's consider their statements. The first statement is the tax levied is 5%. So we don't know what is the cost price, but say suppose this is cost price. So if tax levied is 5%, tax price becomes cost price into 1 plus 5%. Now I don't know the relationship between tax price and selling price. Nothing is given about the selling price as such. So just using this information, I can find out the relationship between cost price and tax price, but not between tax price and selling price. So if I don't know that relationship, I cannot answer the question. So statement 1 alone is not sufficient for me to answer the given question. Statement 2 is, let's say, take a look at the statement 2. The second statement is the tax price of 12 products is equal to the selling price of 8 products. So 12 times tax price is equal to 8 times selling price. So what is selling price by tax price? This ratio is 12 by 8, that is 3 by 2. Now if I know this, I can substitute it over here. This is essentially selling price by tax price minus 1 times 100%. So if this is 3 by 2, if I put it over here, this is 3 by 2 minus 1 into 100%. So this is half into 100%, so this is 50%. So using statement 2 alone, I can find out that the profit percentage is 50%. So I can answer the question using statement 2 alone, but not using statement 1 alone. So the right option to choose is option B. Very simple if you know the formula. So make sure that you know every single formula that is in profit and loss. You should not make any mistakes in these type of questions. So now let's take a look at the next question. Bhavna alone takes 170 days to complete a project. If Ajay, who is twice as efficient as Bhavna, and Chandu, who is 60% less efficient than Bhavna, starts working on the project together, find the number of days in which all three of them can finish the work. So this is a time and work kind of a question. How do you solve these kind of questions? You use something which is called as a unitary method. So what I do is, generally I assume some convenient value for the total number of units of work that has to be done. So if it takes 170 days and the rest of the information is mostly 60% less, twice as efficient, I'll say that let there be 1700 units of work. to be done. The total work or the project is basically 1700 units. Bhavna takes this basically comes from a round figure being multiplied to 170. So if Bhavna takes 170 days of to complete the project, what does it mean? That means Bhavna speed is basically 10 units per day. She does 10 units per day. Ajay is twice as efficient as Bhavna. So if Ajay is twice as efficient as Bhavna, he does 2 times 10 units, so he does 20 units a day. And Chandu is 60% less efficient than Bhavna. If he is 60% less efficient than Bhavna, his value is 100 minus 60%, that is 40% of Bhavna. So 40% of 10 is 4 units a day. So Chandu does 4 units a day. So if they work on a project together, if people work together, you have to essentially add up how many units they individually do. Bhavna will do 10 units, Ajay will do 20 units, Chandu will do 4 units. If they work together, they do a total of 34 units per day. So if they together do 34 units per day, how many days will they require? So the number of days required would be 1700 units. That is the total amount of work that is to be done divided by 34 units per day. So this would be the number of days divided by this by 50. So I get 50 days. So if they work together, they will take 50 days to actually complete the work together. So the right answer would be option A. This became very simple once I assumed a nice round figure of 1700 units. So generally you can either start with 1700 units, or essentially if you have multiple number of days, so suppose this was 170, 120 or anything of that sort, you take the least common multiple of 170, 120 and assume that to be the number of units of work that is there. Once you say that is the number of units of work, divide by that, you get each one's contribution per day or how many units of work that they are doing together per day, add them together if they are working together, add them sequentially if they are working one after the other, subtract them if they are working against each other. So basically you have to figure out, once you figure out how many units of work is done by each of them, you have to just figure out how to put them together. If they are working together, you just add them up. If they are working one day, Bhavna is working, second day Ajay is working, third day Chandu is working, then you have to say, okay, on day 1 10 is done, 10 units are done, on day 2 20 units are done, on day 3 4 units are done, so 34 units are done over 3 days or something like that. So basically once you break it down into units, you just have to put it together to find out how many days are required. So that is basically how you solve questions of this type. Now let's take a look at another question which is based on interest. So question is, Ram initially has rupees 10,000 which he decides to invest in equal amounts in 2 schemes A and B respectively. Scheme A is the interest is 10% per annum which is compounded semi-annually for a period of 2 years. Scheme B is the scheme is in simple interest of 12% per annum for a period of 2 years. So he decides equal amount, so he is going to put 5,000 in this one and 5,000 in this one. What is the final amount with Ram after 2 years? So we have to find out the total amount at the end of 2 years. So what is the compound amount with compound interest? So amount with compound interest is principal times 1 plus r times raised to the number of term or number of units that are there. Here this is semi-annually, so if it is 10% per annum, it is 5% per half per semi-annual this or per 6 months, and if the time period is 2 years, that is 4 half years, so it is 5% compounded over 4 terms. So the amount would be how much? This would be 5,000 into 1 plus 5% raised to 4. So whenever you have something like this, you can use binomial expansion. So 1 plus 5% is basically 0.05 raised to 4. So according to binomial expansion, if you have a plus, or I would rather simply put it as 1 plus x raised to n, you can write this as 1 raised to n, that is just 1, plus nx plus nc2x square plus nc3x cube and so on. Now if you consider 5%, by the time it is x, it is 5%, okay, 0.05. X square would be how much? This is 0.0025. X cube would be how much? That would be 0.00125. So 125 and 6, 0.00125. By this point of time, it is it's just a rounding error at this point of time. So you can ignore x cube onwards. So I would actually ignore all of it. So basically 1 plus x raised to n is essentially 1 plus nx plus nc2 x square. So this would be how much? 1 plus nx is basically 4 times 0.05 plus 4C2, that is 6 times. This is essentially the combinations formula. If you don't know permutations and combinations, just take a look at what is a combination. 4C2, that is 4 combinations of 2 out of, choosing 2 out of 4, that can be done in 6 ways. So that is 6 into 0.0025. So this will be equal to how much? This is equal to 1.2 and 1.2150. So this is equal to 1.2150. So if this is equal to 1.2150, 5000, this would be multiplied by 5000 of this. I will keep it as it is because I also have to consider the scheme from the second is. So the second scheme is a simple interest for 12% per annum, this. So what is amount from simple interest? That is basically principal plus PRT divided by 100. So that is basically P plus P into 12 into 2 divided by 100. So this is essentially 24. So that is basically 1.24 times principal. Principal is 5000. So that is 1.24 times 5000. If I add them up together, what do I get? So the first part is how much? First part is 1.2150 times 2000 and the other is 1.24 times 2000. So the sum would be basically A1 plus A2 will be equal to 5000 times 1.21 and 5000 times 1.24. So that is 1.2150 plus 1.24. If I add them up together, I get 5000 times this is how much? 2.4550, right? 5054550. So 5000 times that, so that is 2455 times 5. So if I do this multiplication, how much do I get? This is 25, 27, 22, 12. So this would be around 12,275. We don't have exactly 12,275, but that is because we kind of approximated down when it came to our return from the compound interest. So the closest answer is 12,277. So the right answer would be option A. So the answer to this question is option A. So this also tells you how you should round down things, how you should calculate compound interest, how you should calculate simple interest. Both formulas are super important. These are how you solve questions based on interest. Now let's take a look at the next type, which is data interpretation. Here we'll basically have to interpret data that is given in the form of a pie chart. So if you can interpret data of this pie chart format, then you'll be able to solve this question. So what is exactly a pie chart? A pie chart gives you a distribution of things. So in this case, you have expenditure, okay? So expenditure, if I consider how much percentage of the expenditure is different things. So this says that 30% of the total expenditure is food. 35% of the total expenditure is clothing, 12% of the total expenditure is rent, 13% of the total expenditure is children, 10% is miscellaneous. So what does this mean? So suppose your 100 rupees is the total expenditure, okay? Then of that 30 rupees is going to food, 35 is going to clothing, 12 is going to rent, 13 is going to children and 10 is going to miscellaneous things. So that basically means that basically of the whole 30% is food, etc. So that is how you read a pie chart. So now that you know how to read a pie chart, let's consider the question. If there is no other expense apart from these 5 expenses and the expense of food exceeds the expense on children by $3,000, what is the total expense of the household across all components from the miscellaneous expense? So consider that, let's say the total expense suppose is X, okay? Total expense is say some X value. So what would be the amount that is there on food? Food is 30%. So 30% of X minus what is the expense on children? That is 13%. 13% of X is equal to how much? This is 323,000. Okay, $1,000. So what does this mean? This is 17% of X is equal to this much, $323,000. So what does X equal to then? X will be equal to divided by 3, this is 323. So divided by 17 would be how much? This 323,000 into 100 by 17, because it is 17% essentially. So divided by 17, this would be 115, so 19. So 19,000 into 100, so that is 1900 000. So this would be 1.9 million. So the total expenditure is 1.9 million dollars. So if that is the case, what is the total expenditure of the household across all components apart from the miscellaneous expense? So the miscellaneous expense is 10%. So apart from that, the rest would be 100% minus 10%, that is 90% of x. So 90% of x is how much? 90% of x is 1.9 million into 90%. So this is basically equal to $1.71 million. So that is option A. So this way you can easily calculate. This is mostly based on percentages, but percentages plus interpreting of a pie chart. So you can have pie charts, line charts, bar charts. You should be able to interpret all sorts of charts to be able to solve these kind of questions. Now let's go to the last question, which is based on a scatter plot, again a data interpretation question. So the question is, the following graph represents the frequencies of certain data points in a data set. So this is also set theory as such. The data has no other values if x is the absolute difference between the mean and the median of the data set. Which of the following represents the correct value of x? So if this is the frequency plot, okay, what can you tell about the set as such? This represents frequency of a value. So 3 comes 3 times, 4 comes 4 times, 5 comes 4 times, 6 comes 2 times, 7 comes 3 times, 9 comes 4 times. So what is this set essentially? This set is essentially 3, 3, 3, 5, 5, 5, 5, 6, 6, 7, 7, 7 and 9, 9, 9, 9. If this is the set, what is the median of the set? So this is leave 4, leave another 3, leave another 3. So this would be, median would be how much? This is 7, this is 7, so 14 plus 2, so this is 16 of this. So the median would be the average of these two values. So the average of these two values is how much? 6 plus 6 by 2, that is 6. So the median would be 6. Now we have to find out what is the mean of this set. Mean of this set would be basically, these are how many values? These are 16 values. So the sum of all values divided by 16 would be the mean. So mean would be how much? This would be equal to, sum would be 9 plus 20, 29, 29 plus 12, 41, 41 plus 21, 62, 62 plus this is 36. So that would be 98. So that is 98 by 16. 98 by 16 would be how much? 49 by 8. So this would be 6.1 by 8 is 125. So this would be, mean would be 6.125. If it is 6, this is 6.125. What is the difference between the mean and the median? That is 0.125. So what is, this is x is equal to 0.125. So what can we say about the value of x? That is between 0.1 and 0.125. So the right answer is option 0.1 and 0.15. So the right answer is option B. So this way, once you actually know what the set is, it becomes easy for you to actually find out the mean and the median. The graph had to be converted to set, and from the set you had to use mean and median descriptive statistics to get to the answer. So as you can see, this is like, if you know the basics, all of these questions are fairly doable. Many of them are actually in fact formula based. So having a good hold on all formulas is very, very important. Now with this particular video, you have a good idea of what all information is needed. What is the course, what is the syllabus. But now that you know the syllabus, I would urge you to please do check out our GMAT Point website. So in the GMAT Point website, we will be giving you a lot of information, a lot of tests to actually crack GMAT. We will have a lot of daily tests we call daily target. So these give you 5 questions every single day that you should solve in order to crack GMAT. The second resource that that is available at GMAT Point is basically practice tests. So we will also have a lot of practice questions that you can use to solve for each of these topics, from arithmetic, algebra, geometry, both in problem solving format as well as data sufficiency format. And once you can start taking those tests, it becomes easier for you to actually, once you have the practice, it becomes easier to solve these kind of questions. So both in the form of daily target and practice questions, you will be getting a lot of practice at GMAT Point. Also, we'll be writing a lot of notes and blogs on GMAT, as well as on how to prepare for GMAT. So please do check out all the resources that are available at GMAT Point. Please do subscribe to our channel so that you keep on getting more updates about videos of this format, and so that you can keep ahead with all the free resources that we have to offer. Thank you for tuning in.